AI tools are transforming scientific research and publishing. They also raise significant questions about accountability, transparency, and reproducibility. How can we harness AI to uphold scientific integrity while leveraging its potential to advance knowledge? I'm Dr. Kirsten Bibbins-Domingo, and I'm the editor-in-chief of JAMA and the JAMA Network. In this episode, I interview Dr. Marcia McNutt, a geophysicist and the 22nd president of the National Academy of Sciences. We'll discuss the opportunities and some of the challenges for what generative AI in particular means for human researchers in advancing scientific knowledge. Welcome, Dr. McNutt.
Well, thank you, Kirsten. It's a pleasure to be here. Thank you very much for this opportunity.
So, Marcia, you're an accomplished scientist. You were an editor of a major basic science publication, Science, and you're now the president of the National Academy of Sciences. So tell our listeners first, what is the National Academy of Sciences and what type of role does that institution have when we think about these new innovations that challenge and provide opportunities in our field?
Absolutely. So the National Academy of Sciences has been around for more than 160 years. It was founded by Abraham Lincoln during the darkest days of the Civil War, and he wanted the scientists on his side. He wanted to be able to consult with the nation's top scientists whenever there was an opportunity for evidence, whether it's of basic science or engineering or medicine, to better inform public decisions. So over that length of time, of course, the National Academy of Sciences is now joined by the National Academy of Engineering and the National Academy of Medicine, and we have served as an apolitical, unbiased reservoir of information to help the nation make better decisions with respect to disease, better decisions with respect to the implications of new technologies, and also ways that we can use evidence to predict the future. What are the likely outcomes of different policy decisions? How can science better inform that?
It's so interesting to think about this during the time of Abraham Lincoln, but certainly the need to have science inform policy decisions in various sectors is one that still is present today. And we're thinking about that with AI. That's our discussion today. So what might be the role, or what has been the role of the National Academy of Sciences in thinking about these new generative AI tools and what that might mean for science?
So I would say that the National Academy of Sciences activated its members, its employees, its committee structures very early on, especially in the days of generative AI. Now, let me start by saying there have been bespoke applications of AI that have been around for decades. With my background as a marine scientist, we have used AI on underwater vehicles for decades because actually there is no way to effectively communicate through salt water with complex engineering devices in the ocean, whether they be autonomous observatories or autonomous underwater vehicles. AI was the one way to actually get the most out of these technologies at a time when a direct connection to the human brain is not possible. But I think the concerns that I have heard voiced most often have to do with large language models or generative AI, because this is AI moving into a new realm. Whenever we put AI on underwater vehicles or in spacecraft or anything else where it's difficult to connect to the human brain, we could always test whether the AI was doing exactly what we wanted it to do. So one of the first topics that came up at the National Academy in terms of concerns about generative AI had to do with simply the norms of science themselves. As scientists, we value work that is reproducible. You can put the same query into a generative AI model and get two different answers.
Yeah.
So reproducibility is just not part of the generative AI way of working. The other thing we really respect in terms of a norm of science is attribution. If you are using work that was previously done, you have to cite who did it and what they said. Well, for people who have used generative AI, you know that this stuff comes out and you have no idea where it came from. And sometimes when they provide references, they're totally phony. They were made up. They don't even exist. So attribution is another problem. A third is transparency. We value in scientific publishing complete transparency of how we got to an answer. What did we use? What was our thinking? What were our preconceived assumptions going into it? We know nothing of that with generative AI. So we held a retreat in which we invited some of the leaders in AI from industry, from academia, from government, to explore what can we do to ensure that the norms of science are promoted and are supported in this brave new world we're coming into. And we started with the most important thing was human responsibility. We have to hold the users of generative AI responsible for how they use it and what they conclude. Because if they themselves haven't taken the time to double check what's coming out of generative AI, then that's on them. But we have also pushed for the developers of AI to make it easier for users to understand what were the preconceived starting points from any solution. We also have made it imperative that researchers who use generative AI cite that they have and show exactly what in their research was the result of generative AI and explain what they did to verify the results. So I think that is one of the biggest issues we've dealt with. But one of the concerns that I've also had in trying to navigate this brave new world is the fact that I don't see the public sufficiently involved in this. And we have a number of other cases of new technologies that were very promising, but got off to a very bad start because of the lack of public understanding, engagement, and a particularly understanding of the safeguards, the appropriate uses, and the misuses. One good example that I'm sure you've had experience with is GMOs. Mm-hmm. Look at how quickly the public, particularly in Europe, became very, very suspicious of GMOs.
Genetically modified organisms, or
Yes.
using genetic technologies to make better plants, better things that enter our food supply and things like that.
Yes. But with these genetically modified organisms, I think so many people saw only industry engaging in it. And so they felt that the only applications of genetically modified organisms was for corporate profit. Mm-hmm. Roundup Ready corn, items like that. Mm-hmm. And so the lesson I take from that is we have to be very concerned about the fact that academia is being priced out of AI research. The size of research grants is simply insufficient to support new model development in universities. And I fear that if it is only industry that is promoting AI and that is developing it, we will quickly lose public trust.
Mm-hmm. I want to start with where we started at JAMA and our network of journals with the human responsibility. And so I think when you have a new technology that is clearly so powerful and has so much potential to really further the science, for publishing to further how we can communicate more effectively across a variety of different modes of communication, It's really exciting. And then the only thing you can do in the end is to say that humans ultimately still bear the responsibility. So we published early, at the beginning of this year, saying that it is still humans who sign the author integrity form when you publish articles, right?
Mhm.
And when we had published that, it was amazing that ChatGPT had already been indexed as an author on several publications. And it just speaks to how fast we start to say, well, yeah, this would be fine if I had this tool could actually be an author. And in the end, ultimately, we have to hold ourselves accountable as individual researchers, as a collective scientific and medical community to this. So I think that's one of the most important things. I think we as scientists, as I'm a clinician as well, are learning the tools, learning how to use them effectively, how to use them responsibly, and we have to hold ourselves accountable. We worry about, can I trust that figure in that paper? Can I trust that? And we figure out rules around that. But really, when we lose the trust of the public, if the public can't trust in that same way, that is another level of loss that is really important for our collective communities.
I agree completely. And we've already struggled in recent years with trust in science. It all started with climate change, with people feeling that the efforts they would need to take to counter climate change were going to be so distasteful in terms of their quality of life that they didn't want to do it. I never felt that human health would fall victim to the same lack of public trust, because it seems to me there is no special interest group as there was for tobacco or as there was for oil. There's no special interest group that is going to take pride out of trying to discount science because it's in their personal financial benefit to make sure that climate change mitigation or that ceasing tobacco use, they don't want to see that happen. But when it came to human health, I honestly couldn't believe that we were dealing with misinformation and people putting out statements that were actually harmful to people's health. I think it was JAMA that published that paper that showed the difference between the death rate because of vaccine uptake of people who were registered in the two different political parties. And it actually made a life or death difference as to whether you were sucked in by that misinformation.
Yeah, it's an interesting time to think about technologies that can both enable us to bring more information, to have information that we can put on many different types of platforms, that we can create and disseminate from original research articles, publications that might reach a lay audience, might reach audiences in different languages so much more easily, because that is one of the things that these tools do extraordinarily well.
Absolutely.
And so that is such a boon for helping to deliver high quality information to so many more people, especially as it relates to science, as it relates to their health. And at the same time, if more people become mistrustful because one can manipulate images, or that's sort of implies there's an intentional aspect of it, but even that we can't quite figure out how to attribute the right citation to that piece of information, or that we can't reproduce that is of concern. So how do we engage the public, or how do we engage other scientists in both the conversations for what we need to do to use these tools responsibly and in a way that we as a community can trust, but also that the broader public can trust?
So I'm not sure I know of any scientist right now that is not engaging with AI. As you say, it is a remarkable tool. There's not a day that goes by that I don't use AI. But I am very careful about how I use it. And I am very suspicious anytime I get something back that looks odd. One great example of that was I had a whole bunch of people I had to introduce once at a National Academy meeting. So I asked GPT, can you just give me a 4-sentence summary of why this person is so terrific or whatever? All 4 of them were winners of the National Medal of Science, according to the AI, when actually none of them were.
Ooh.
And it was simply because AI had inferred,
Yeah.
based on their distinguished background,
Yeah.
that of course they must be recipients of the National Medal of Science, even though that was demonstrably wrong by going to the National Medal of Science webpage and look at who has been awarded it.
Well, it's a great example both of the widespread use and why we still all have to have that healthy skepticism and sort of understand these tools better. So, what would you say? You've been a journal editor and you now run an organization that is convening and helping to really provide the thought leadership on what we should be doing. Is it enough for our journals to say, well, yes, you as an author, you're responsible, as you always have been, for the integrity of the work that appears on these pages, that when the different major media outlets pick up this work, that they can say, well, we trust that it's in these pages and that we trust that the authors have said this, therefore the public should trust that these findings are important. Is that enough? Do you think that we're going to be using more and more tools to help us? What do you think?
Yeah, I'm just not sure that that will be enough, because it's sort of like saying to people, well, we have this tool. You don't understand it. We don't really understand it either, but we're going to use it.
Yeah.
And so you should trust it. That's not going to get us anywhere, I'm afraid. So I would say that, first of all, disclose, disclose, disclose.
Mm-hmm.
It's so important in every paper to say at every step of the way what tools were involved and what you learned. Disclose, disclose, disclose how you checked the results.
Mm-hmm.
You can only build trust. This is actually part of science.
Right.
And it's not until it's been reproduced, ideally with similar results, but also extended, that we found that the results were so strong that we could actually make predictions in other systems that were proven to be correct, which is a completely independent way of verifying results. And I think this is the same approach we're going to have to take with generative AI.
Yeah, so in the end, the enduring pieces to the scientific enterprise really are about the transparency, are about the rigorous reporting, are about the reproducibility for other scientists, and that's ultimately why we don't have confidence in one article or one experiment, but that the entire enterprise, the ability to reproduce and to make corrections if things are wrong, that is why we hope that we're able to trust the entire scientific process.
Yeah, and it's basically independent verification.
Mm-hmm. Mm-hmm.
There was so much basic science that went into the creation of chips, for example, that we have in our cell phones and our computers and everything else. No one distrusts that science because the devices actually work.
Mm-hmm.
They work as they were designed and intended based on the physics that was learned through that research. We're going to have to get to that stage with generative AI too, where the proof is in the results. But that's going to take disclosure and testing at every step of the way. And, I try to focus mostly on impacts of AI in science. But as you well know, AI is going to be pervasive everywhere. And some of the applications will be testable. Others may be a little bit more difficult. For example, everyone's concerned about how AI will be used in image recognition. I heard this fascinating story on the news the other day about a grocery store that instead of putting paper price on a shelf for what these items cost, is thinking of dynamic pricing, where you have a little LED. And so if there's a run on toilet paper because people think another disease is coming, the store can jack up the price of toilet paper to try to discourage that from happening. And I thought to myself, can you imagine dynamic pricing being combined with AI so that what happens is as you walk up to the shelf, the AI determines, oh, she can afford to pay more. Let's up the price by another $1. And someone else walks up and it says, oh, this person looks like, they're on hard times. We're going to lower the price for them. These applications are not pipe dreams. They could actually happen.
Absolutely. It sounds like there's going to be a lot of need for more convenings of the National Academy of Sciences and scientists to figure this out. I think your point also of having the scientific community actively engaged in this so that it is not just with the large corporations, because that is where much of the advances are coming right now. I think that's a key piece. And I guess I would really underscore that as a medical community, as a scientific community, that even if the actual workings of these technologies are not always obvious because of the disciplines we all have trained in or come from, understanding what they mean for our fields is important, because ultimately the principles by which we self-govern really require that all of us know enough to engage so that it isn't something that is just left to the large corporate interests, which are clearly there.
Yes, so I recently put together a presentation on activities that the Academy has in AI. 65 slides of different activities that we have underway, ranging everything from how AI can be used to help with very, very difficult mathematical proofs, to how AI can be used for better natural hazard prediction, like hurricanes and floods and things like that. Also looking at how AI could exacerbate climate change through the dramatic power requirements that are needed. And AI in social sciences and in life sciences research, right before generative AI came on the scene, a lot of scientists were recognizing we had very, very large data sets that were very, very difficult to find patterns in them. But now with AI, that's one of AI's major strengths.
Yeah. Well, there will be more to come. It's an exciting time. There is clearly a lot of promise. And I love that you started out by talking about, in your field, using AI tools for a whole host of reasons. But clearly what's ahead of us is also very exciting. And I think it does require that all of us engage. And it's great to see that it's a priority of the National Academy of Sciences.
And Kirsten, I just have to mention this fantastic statement I recall at the last NAS annual meeting. We had a panel on AI. And one of the questions from the audience was, how will we ever trust AI since even the engineers don't understand exactly how it works? And one of the panelists said, we don't understand that for the human brain either. And yet we still have mechanisms for building trust in our fellow humans. And I think that's going to have to be where we start for building trust in AI.
Well, it will take humans building trust with each other and then thinking about that with regard to these technologies. I couldn't agree more. Marcia, it's been a pleasure speaking with you, and hope you'll come back and talk with us about what the academies are doing as the technology continues to evolve.
Well, thank you, Kirsten. It's been a pleasure. And as I say, there's so many people at the National Academies who are really dealing with all aspects of this, and they'll be really happy that JAMA's on top of it too. So thank you.
And to our audience, thank you for listening. We welcome comments on this series. We also welcome submissions in response to JAMA's AI and Medicine call for papers. This episode was developed and researched by Associate Editor Dr. Yulin Swen and was produced by Patrick Lyle and Daniel Morrow at the JAMA Network. I'm Dr. Kirsten Bibbins-Domingo. I'm the Editor-in-Chief of JAMA and the JAMA Network. Subscribe to the JAMA Network YouTube channel and follow JAMA Network podcasts wherever you get your podcasts. Thank you for listening, and until next time, stay informed and stay inspired.
This content is protected by copyright by the American Medical Association with all rights reserved, including those for text and data mining, AI training, and similar technologies.